Hello guys, and then welcome to another video. Okay, so in this video this will be a build up to ordinary differential equation. Okay, initial and what boundary value problems. So when we talk about initial and boundary value problems, we basically use certain values, okay, values given at x and then y, okay, to substitute into a differential equation, an unknown differential equation, so that we get to find the exact form of the differential equation. Okay, that's what initial and boundary value problems are all about. Okay, so in this video we'll be very concise and then go straight to the point. Okay, so let's talk about initial value problems. Okay, so initial value problems are always represented by what? IVP. Okay, so now when we talk about initial value problems, they are basically values which have the same x components. Okay, so they always have the subsidiary conditions to be given at x. Okay, so let's say you have a certain differential equation like y prime, okay, plus what? 2y prime, okay, equals what? E exponent what? X. Okay, and then you are given the conditions at y. X is what? Pi. Okay, there's pi. Okay, and then we have what? 1, and then what? Y prime, okay, at x to be pi again, okay, equals 2. Okay, what I'm trying to say is that whenever you are given an initial problem, okay, whenever you are given an initial value problem, or you want to identify whether an expression is given in the form of an initial value problem, the x values, components of the x values remain the same. Okay, so from here we know that these are what? X. Okay, and these are also what? X. You could notice that the x value for this one is pi, okay, and that for this one is also pi. It means that this is an initial value problem. Okay, the components of x, or the subsidiary value, is what? The same. Okay, so from here this is the same as y equals what? 1, and then what? S equals what? Pi. Okay, and then from here this y prime, okay, equals what? 2, and then what? S equals what? Pi. Okay, so from here we notice that both the initial conditions for x, okay, in two different states are what? The same. Okay, that's what we mean by initial value problems. So initial value problems always have both the subsidiary conditions at x to be the same. Okay, that's what it means. So you can notice that the y values are what? This y1, y to be what? 1, and here y prime is 2. You could notice that they are different values, but for x values you can notice that they are what? The same. S is pi over here, and then x is also pi over here. Okay, yes, so this is what we are trying to this is what we try to prove when we talk about initial value problems. Okay, so now let's look at boundary value problems. Okay, it's always represented by what? BVP. Okay, so now for boundary value problems, unlike the initial value problems, the boundary value problems have different value for y, okay, and then different value for x. So let me just write this example. You have y prime, okay, plus 2y, okay. Oh, this is, let me clean this one up and write this very clear. Okay, we have what? 2y prime, okay, equals what? E exponent what? X. So from here we know that y of x is what? 0, and then that's 1, and then you have what? Y prime, okay, of 1, okay, is equal to what? 1. So you can notice that the subsidiary conditions are given at different values of x. Okay, so from here you could write that y is what? 1, and then what? S is what? 0. Okay, and then from here you can also write that y prime is what? 1, and then s is what? 1. Okay, so we can notice that the subsidiary values for x are different over here. Okay, the values are different over here. These are x. Okay, So from here we could notice that for initial value problem, that's the only thing you need to know, so that you could identify whether an equation is an initial value problem or what, a boundary value problem. So for initial value problems, the x values are what, the same. Okay, from here you have x to be what, pi, the same applies to here. And then for boundary value problems, the x's are different. Okay, you have x to be 0 over here and the what, x to be 1 over here. Okay, now let's take some examples. Okay, examples on initial and what, boundary value problems. Okay, so in case you've been given, there's an example. Okay, so in case you've been given this, okay, so you have this and then you have what, that's okay, plus c2, okay, e exponent what, 3x. Okay, this is a general solution, okay, of a differential equation of this form. Okay, so you have y prime prime minus 2y prime, okay, minus 3y is equal to 0. Okay, now and then you've been given the conditions to what, y to be equal to what, 3, okay, when x is equal to what, 0, and what, y prime, okay, to be equal to 4 when x is equal to what, 0. Okay, so from here you could notice that this is what, an initial value problem, IVP. Okay, this is an IVP. Why is this an IVP? This an IVP because the subsidiary values, okay, that's x, are the same. The values given at x are the same. So x is 0 over here and then x is what, 0 over here. So let's see how we could solve this. Okay, so now we have our solution, okay, to be our solution, okay, to be what, we have what, y equals what, c1 e, okay, x, okay, plus what, c2 e 3x. Okay, so now from here, let's say we have at what, let's use the first condition. We have what, at y equals what, 3 and then what, s equals what, 0, we have this, y is what, 3, so we have 3 equals what, c1, okay, e exponent minus 0, okay, plus what, c2 e exponent what, 3 times what, 0. Okay, so in simple form we could write 3 what equals what, c1, because e exponent minus 0 is what, 1. Okay, and then plus what, c2, so this will be our what, equation 1. Okay, same applies to here, 3 times 0 is 0, so e exponent 0 is what, 1. Okay, so that's our first equation. Now let's look at the second condition. We have what, y prime equals 4 and then what, s equals 0. Same initial value problem. So we have what, at what, y prime equals 4, okay, and then x equals 0. We have this equation, okay, this differential equation, which is this, e exponent 3x, okay, to be what, so it means that you have to take the first differential, okay, that's y prime. So taking the first differential will give us what, when you differentiate this you get minus c1 e exponent minus x, okay, and then when you differentiate this you get what, 3 c2 e exponent what, 3x. Now let's substitute the values. Okay, y prime is what, 4, so we have what, 4 equals what, and then this is what, 0. Same applies to this point. This will give us what, this will give us minus 0, okay, and then e exponent minus 0 is what, 1, so we have what, minus c1, okay, and then plus this will also give us what, 0, because 3 times 0 is 0, and then e exponent minus 0 E exponent 0 is what? 1. Okay, so we have what? 3c2. Okay, this will be our second equation. Okay, so now we can solve this simultaneously. Okay, so when you solve this simultaneously, this equation, okay, so we have from 2, okay, so we have this 3, okay, is equal to what? C1, okay, plus C2, okay, this is our equation 1, okay. So when you solve this simultaneously, you can use the calculator to solve this simultaneously, or you can just use your normal algebra to prove this. But we will notice that C1 is equal to what? 5 on 4, okay, and then what? C2 will also be equal to what? 7 on what? 4, okay. So this means that our general what? Equation, this general form of the equation, okay, this is the general form of the equation. So this general form of equation will then look like this, okay. This will then look like this because we found what? Our values, okay, our C1 and C2 values. So this will look like y, okay, equals what? C1 is what? 5 on 4. This is 5 on what? 4. And then E exponent what? Minus x. And then we have plus what? C2 is what? 7 on 4. So we have what? 7 on what? 4. And then we have what? E exponent what? 3x. So this is our final answer, okay. So this is how you solve an initial value problem, okay. So let's take another example on boundary value problem so that you get to understand it better, okay. So this is our initial value problem, okay. You need to know that for initial value problems, okay, initial value problem, the x values or the subsidiary values have to be the same, okay, but the y values, the dependent values have to be what? Dependent, and then what? The differential have to be different, okay. And then for the subsidiary, okay, x values have to be what? The same. Okay, let's look at another example. That's for what? Boundary value problem, okay. So we have what? Another example, okay. So we have maybe this is another example, example 2, okay. So we have what? This differential equation, okay. Have this differential equation, okay, and then we've been given the conditions at what? Y at what? Pi on what? Pi on 8, okay, to be equal to what? 0, okay, and then we have what? Y equals what? So let me clean this one up, okay. So we have what? Y, okay, on what? Pi on 6, okay, to be what? Equal to what? 1, okay, and then we have the general form of the equation to be what? Y equals what? C1, okay, C1 sine what? 2x, okay, plus C2, okay, cos 2x, okay. So let's find our solution, okay. So from here you can notice that we have our equation to what? With our missing variables, okay, sine what? 2x, okay, plus C2, okay, cos of what? 2x, right. So we're taking this at what? Y, okay, pi 8, okay, cos 0, okay. This is the same as this form, okay. Remember, this is the same as this, okay. So it means that our x value is what? Pi on 8, and then our y value is what? 0, okay. This is the same as this, okay, and then x value to be equal to what? Pi on what? 8. Remember this, okay. So now let's see how we find our values, okay. So we have what? Y to what? 0, okay. We have 0. That's from here, okay. From this expression we have 0 equals what? C1, okay, sine of what? 2 times what? Pi on what? 8, okay. We are doing the substitution, plus what? C2, okay, cos of what? 2, and then what? We have what? our x value to be what? Pi on what? 8. Okay, now note that whenever you are given what? An expression and then it is in this format, okay, you can just use the calculator to find your values, okay, by just using what? The radians, okay. So whenever you put your calculator in the radians form and then you punch this, it will give you the answer in what? In the radians form. This is what I mean, okay. So let's find our calculator, okay. So we have what? Calculator over here, okay. Yes, let's find a calculator, okay. Right, okay, let's see. So let's say you have a calculator over here, okay. So we have that, okay. Yes, trying to pull up this calculator, okay. Yes, so let's say we have a calculator, okay, and then you put your calculator in radians. It's in degrees, okay. This is in degrees, so click on shift and then what? Mode, and then you punch what? 4. You click on 4, okay, and then you punch what? Pi on 8, okay. So shift pi and what? Divided by 8, okay. This is what you get, okay. This is what you get. It means that it's what? In what? Radians, okay. Now when you multiply sine or cos by that value, so from our question we have what? Cos 2 pi on 8. So let's point that we have cos what? 2 what? Pi on what? 8, okay. Let's see our answer, okay. This is root 2 on 2, okay. And let's say we have what? Sine, okay. Let's say we have sine, okay. Okay, yes, you could notice that we have what? Root 2 on 2. The same applies to this question, okay. So sine 2 pi on 8 will give us what? Root 2 on 2, okay. Same applies to cos 2 pi on 8, okay. Cos 2 pi on 8 and then sine 2 pi on 8, okay. So from here you could just simplify this, okay. Could just simplify this over here, okay. So we have what? 0, okay, equals what? C1, because you know that sine 2 pi on 8 is what? Root of 2 on 2, okay. Root 2 on what? 2, okay, and then plus C2, okay, to be equal to what? Root what? 2 on 2, okay. These are what? Equation 1, okay. It means that cos 2 pi on 8 is what? Root 2 on 2, just like I showed you when you point that on your calculator, okay. You point that in your calculator and then you convert the degrees into radians, okay. That's how you find this value, okay. So now let's say this is equation 1. So let's say at y, okay, at y, which is what? Pi on 6, okay, to be equal to 1, okay. Note we are solving for what? Boundary value problem, okay. So let's see, we have what? From this expression, okay, from this expression, okay, we have what? Our y, okay, y to be what? 1, which is equal to what? C1, okay, and then what? Sine of what? 2. X is what? Pi on 6, okay, pi on 6, okay, and then we have what? Plus what? C2, okay, cos 2, okay, cos 2, and then we have what? Pi on 6, okay. The same thing applies to this. When you convert your calculator into radians and then you punch sine 2 pi on 6, okay, you end up with what? Root 3 on 2, okay. So let's say you have 1 equals what? C1, okay, you have root 3 on what? 2, okay, and then plus what? When you punch cos 2 pi on 6, you get what? Half, okay. C2, okay, we have what? Multiply by what? Half, okay. So these are what? Equation 2, okay. Now let me show you what I'm trying to talk about, okay. So when you punch what? When you punch cos, okay, cos 2 pi, okay, on 6, okay, you get what? 1/2 or 1 on 2. And then when you punch sine 2 pi, okay, on 6, you get what? Root 3 on 2, okay. That's what I'm trying to say, right? So now let's dive right into this. So when you solve these two equations simultaneously, okay, C1, okay, root 2 on what? 2 plus C2, okay, root 2 on what? 2, which is what? Our equation what? 1, okay. This is our equation what? 2. When you solve this simultaneously, you end up with what? This values C1 to be equal to what? 2 on what? Root 3 minus 1, okay, and then we have C2, okay, have C2 to be equal to what? Minus 2 on what? Root 3 minus 1, okay. So putting it in this form, okay, putting this in this form, okay, so putting our equation in this format, okay, so you know that this is our equation, okay, this equation, okay, so putting it in this format, so we have the equation to what? Y equals what? C1, okay, sine what? 2x, okay, plus C2, okay, cos 2x, okay. So now we know what? Our C1 and then C2, so we just substitute that into this equation. So our equation will be what? Y equals C1 to what? 2 on root 3 on what? Minus 1, okay. So C is what? C1 is what? Root 3 minus 1, okay, sine what? 2x, okay, plus our what? 2, okay. C2 is what? Minus 2 on what? Root 3 minus 1. So you can just omit the negative, okay. You can omit the positive sign, okay, and you just use negative. So we have what? Minus what? 2 on what? Root 3, okay, minus 1, okay. Then we have what? Cos 2x, okay. You can further simplify this. Okay, this format, okay. So further simplifying this into the simplest format, we have what? Y equals what? Just since we know that 2 on what? Root 3 minus 1 is also here, okay, so we just factorize, okay. So we have what? 2 on what? Root 3 minus 1, okay. Factorize 2 on root 3 minus 1 out, then we have what? Sine what? 2x, okay, sine 2x minus what? Cos 2x, okay, cos 2x, okay. Yes, so this brings us to the end of the what? Initial value problem and then boundary value problem. I hope you understood this section, okay. So in the next video we'll be talking about ordinary differential equations, okay. Kindly subscribe, hit on the bell icon so that you don't miss out on any uploaded videos, and then share, comment your thoughts in the comment section below, okay. You can also ask your questions in the comment section below, and I will see you in the next video. Bye bye.